покушали, вы в хорошем настроении, расположении духа, даже не засыпаете, хотя здесь немножко душновато даже. Что ж, не буду откладывать в долгий ящик. Те, кто не успел еще взять кофе, забирайте кофе, присаживайтесь. And please welcome Alex.
Okay, one moment, everybody. Something terrible has just happened to my slides. Right, okay, excellent. That's perfect. Okay, how is everyone? Do you have a good lunch? Are you feeling sleepy? Yeah. If you want to sleep during my presentation, that's fine. I won't be offended, okay? I'm sleepy too, but we'll get through this. Okay, so let's get started. So a little bit about me. I'm a Java developer. I have been working, oh dear. I have not been working in, I'm not sure why that is happening. Sorry if you bear with me a moment. I will try and sort out what's happening. Right, okay. Hopefully that won't happen again. Sorry for that. Okay, yeah, so I'm a Java developer. I've been working in the Java space for quite a few years now. And I tend to go to conferences and speak on various topics in relation to Java EE. You might have seen me present at these conferences. I hope to be presenting at a few more later on this year. So there's my Twitter. If you want to contact me, by all means do so. I'm happy to speak to any of you about any topic related to anything to do with what I talk about today, and well, anything really. Just talk to me, please. I wrote a book with my co-author Murat Yerna, Java EE Design Patterns. Has anybody purchased this book? I know there's at least one, yeah, oh, one. I know there's these two people who have purchased this book. If you haven't, you can buy it at Amazon, which is currently available for a discount. And also, if you really want this book, you might be able to type the title into Google and find a BitTorrent. But if you want to buy it, then you can buy it from Amazon. And also, it's available in Russian. I discovered today, thanks to Vladimir. Thank you, wherever you are. So, what are we going to talk about? Well, this is going to be quite a nice after-lunch talk about a very simple topic, so not too taxing. So that's exactly what you want. So we're going to talk about design patterns and a retrospective of where design patterns come from and what they're used for. And then I'm going to try and map those classical design patterns to their implementation in Enterprise Edition Java. Then I'm going to look at the context and dependency injection that we have in Enterprise Edition and show how that has helped us, or how that has helped Java to change the way we implement design patterns into something that is actually quite unrecognizable. And I'm going to demonstrate this idea by having a look at Singleton Pattern, which we all know and love, or hate, the factory pattern, Façade, Decorator, and then the Observer. I'm going to have a look at some final conclusions, and then hopefully, if we have time, some questions and answers. If we don't have time for questions and answers, I'll be around all day, so by all means grab me and we can have a chat. So I always like to ask this question because I like to find out where you all are. So hands up those of you who are currently using J2EE. Don't be shy. Okay, and how many of you are currently using Enterprise Edition, 6 or 7? A few of you. A few more? It's growing by the minute. Even more? Okay, excellent. How many of you use Spring? Yeah, yeah. That's what I thought. Okay, this talk is not about trying to persuade those of you who use Spring to use Enterprise Edition. Okay, they're both excellent frameworks, and they both provide the developer with an excellent way of developing enterprise applications. This is just a very simple talk to talk about how Enterprise Edition has changed the way we implement design patterns. So, what are design patterns? Where do they come from? Well, design patterns originated back before even software development was common, way back in the construction industry, and perhaps even before. But it wasn't really until the Gang of Four published their book, Design Patterns, Design of Reusable Object-Oriented Software in 1994, that it really took its place in software development. And in their book, they talk about a number of design patterns under different categories, under creational, behavioral, and structural. And we're going to have a look at some of the most common patterns that they talked about during this presentation. Many of you will be very familiar with these design patterns and how they're implemented in the languages that you use. I want to talk about how they are implemented in Enterprise Edition Java. So what are design patterns in practice? Well, design patterns are the collective wisdom of developers over time. They've developed solutions to problems that are already solved. We can implement a design pattern to our code that solves a problem in a way that we can easily understand. And it provides a common vocabulary among developers. A C# developer can talk about the singleton to a Java developer, and you know what you're talking about. You know what it is. It's a common vocabulary among developers, and it allows us to communicate across languages in a way that is effective and efficient. However, like with everything, using design patterns wrongly causes more problems than it solves. It can create spaghetti code, it can create code that's difficult to understand, that has complicated execution orders, and difficult to maintain. You know, it's a very dangerous way of developing if you're just implementing design patterns to whatever situation you can find. And implementing a design pattern to a situation which is not designed to be used can actually make things worse. So you need to have a good knowledge of design patterns. You need to have a good toolkit of design patterns. And it's very much the case of if the only tool you have is a hammer, then you will see every single problem as a nail. So after the Gang of Four published their book, there was a talk at Java 1 2000 about prototyping design patterns for the Java 2EE platform. This talk became a success, and the speakers published a book called J2EE Design Patterns. Well, the GOF book describes a range of patterns, not all in Enterprise Java, but those that are common in Enterprise Edition are baked into the API. They are there out of the box, ready for us to use. So instead of having to implement them yourselves, the platform has them already to use there for you out of the box. And this has already happened by Java EE 5. Okay? And we're going to have a look at how this has developed. So the Java EE programming model has been simplified substantially over the years. Gone are the XML descriptor files and have been replaced by annotations. Convention over configuration has got rid of the tedious manual configuration that we were needed to do before. And dependency injection hides the creation and lookup of resources. And the way that resources are created is that they are instantiated by the container. They are instantiated by the container, and then they are injected into qualifying injection points marked by inject annotation. And wherever the container finds these points of injection, it will inject the instantiated object. Of course, there are problems if you're using the interface to identify the injection point. The container doesn't know which concrete implementation to inject. So we have the ability to disambiguate using qualifiers. Now, I'll expand on this a little bit further later for those of you who are not familiar with this idea, but that is something that will happen later. And the container will instantiate, by default, all objects that are POJOs. So a simple POJO is automatically becomes an ejectable bean. It's instantiated by the container and becomes available for injection. However, that POJO must conform to JSR 299. I'm not going to go into the specifications exactly of what that is, but there are times when you have beans, you have objects for example, a list that you would like to make injectable, that you would like the container to manage and make available for injection. And there are ways of doing this by using the producer's annotation. And I'll show you some examples of this later on as we go through this presentation. So let's start with the Singleton pattern. Okay, this is a creational pattern. It creates an object, and it creates a single instance of an object. We only want a single instance of this object to exist in our JVM. And if you read the Goff book, it will tell you that the motivation for creating this single object is that we want to create a heavyweight object, an object that is complicated, not complicated, but is expensive to construct. It's an object that we don't want to waste time or wait for its construction. We want it to be constructed and available throughout the JVM for injection. But if you read the Goff book a little bit further, you'll see how the implementation of this, the classical implementation of this, is not very elegant. In fact, it's not quite non-trivial. You get a lot of quite unnatural constructions. You use double-check locking, you have static initializers, you have a lot of boilerplate code that you have to repeat every single time you want to create your object. And you can create objects like, with using enums or with private constructors. It can become quite unattractive. And if you look, and when we look at the way this is done in Enterprise Edition, you'll see how much simpler this is. So let's have a look at that. So this is a very simple class, okay? And quite often the Singleton pattern is used for things such as loggers or pool managers. This is the typical use case scenario. So here we are, we have a logger, and we want to make this class a singleton. Now, in the classical implementation, we will probably have static initializers, double-check locking, a whole load of rather quite ugly and unnatural feeling code. But in Enterprise Edition, we do it like this. That single annotation creates a singleton. It says to the container, I want you to instantiate this class once and make it available to the JVM, and I want it to be thread safe. Okay? This guarantees a thread safe singleton. You don't have to bother and concern yourself with thread safety. This is done by convention, and this is what I mean by configuration by convention. This is a thread safe singleton and is available throughout the JVM. And the JVM knows to create just one because of the singleton annotation. And by default, it is read-locked and access is serialized. So with two calls that come into this, they will be lined up and serialized. So if two threads access it, it's forced into serialized access. And it's injected, into our usage. We want to use it. It looks for an injection point here. It will look for logger, and it will look for the class, and it will inject where it sees the @inject, which we'll see in a moment. But remember, when we talked about the original motivation for this pattern, we were talking about creating a heavy object, constructing an object that took time to construct. And the way we do this in Enterprise Edition is we have a method which contains the expensive construction logic, and we annotate that post-construct. Now, what this guarantees is that when the singleton is instantiated, this method is guaranteed to be called before any client requests are served. So you're guaranteed to have your singleton constructed before any client requests are served. And this is all done thanks to the way the container interacts with this structure, with this code. And these annotations convey these benefits. And yeah, likewise, we can see here, we can inject this bean into our code just like this. However, we might actually want our bean to be instantiated not lazily, which by default it is. In this case, this bean will be instantiated every time you inject it. It will be instantiated on first use. So the first time you inject it, it's instantiated. The post-construct method is called, and it's instantiated. And this is instantiation, lazily instantiated object. However, you might not want that. Your use case scenario might dictate that actually what you want is your bean to be constructed before any client requests are satisfied. You might want it to be constructed during the startup of your application. And we can do this. With a simple annotation, we can say to the container, I want you to construct this object at startup. Now, this is not something that is elegantly possible with classical implementation. You'd have to use static initializers and essentially lots and lots of static structures in order to get this simple situation set up. But that's not all. We can actually make the construction of our bean dependent on the successful construction of another bean. Here, you can see that I am telling the container, I want this bean to be constructed once the database connection bean has been constructed. Perhaps that's because in my construction logic, I rely on a database connection. Okay? So now we're creating this bean, which is eagerly instantiated, and its successful instantiation is dependent upon the instantiation of another bean. This is something that simply is not elegantly possible or easily possible with classical implementation. And Java Enterprise Edition gives us this this functionality with the minimum amount of code necessary. So conclusions so far. Well, as we have already seen, the implementation of the Singleton pattern is markedly different to its classical implementation. Okay? There is substantially less code required to achieve the same results, and even more results. Okay? You've been given more control about when the bean is instantiated. You can instantiate it lazily, by default, or you can instantiate it eagerly. Okay? We have substantially less boilerplate code. I mean, there's very little code. I mean, if you go back and you have a look, and you look at the amount of code that is here, we have literally just four annotations that give us an immense amount of functionality. And it's been, and the instantiation has been enhanced by these annotations. It's now more sophisticated Singleton than what we're perhaps commonly used to. However, there's more. Remember I said that the bean is by default thread safe. Okay, we might be happy with the container controlling our thread safety, or we might not be. We might want to take control of that thread safety, right? Want to take control of the concurrency and manage it ourselves. We can do that. Okay, the container is not all-powerful container that doesn't allow us to do what we want. We can still do what we want, and we can control our concurrency by simply annotating our bean like so, defining the concurrency management type as bean. However, we're still operating within a concurrent environment, and because of that, we need to be careful of thread safety, and method access is important. So we can annotate our methods and have method-level control over the access to these methods. So we can annotate methods that affect change, lock type write, and those that read data as read. Now access to add message will be blocked while it's being executed. And this is great. This is exactly how we want to control our bean. Also, it's interesting to point out as well that actually you can add the lock type to the class level and have the same lock type for the whole bean if you happen to have all read or all write methods. Okay, that's available. But what happens if we're trying to access our add message method and it times out? Because there's a timeout. By default, there is a timeout. And if it times out, you will get a concurrent access timeout exception thrown. Now, we might not like the defaults that the container gives us, so again, we can gain control of that, and we can define for ourselves that in this case, the timeout is going to be 30 seconds. So again, we'll be given more control through the use of annotations on how our Singleton behaves. So, what's good? What's the good? What's the bad? And what's the ugly of this? So we have an enhanced implementation of the Singleton pattern. Okay? We have some specialized annotations that give us some interesting characteristics that our bean would not easily have under a classical implementation. We control startup behavior, we have fine control over concurrency, and substantially less boilerplate code. I was having a conversation recently with somebody who said, well, actually, all you've done is you've swapped boilerplate code for boilerplate annotations. That is a point of view, but still, annotations, I think, are much more intuitive and easier to understand than perhaps the traditional implementations. So what's bad about it? Well, okay, overuse can be a problem. You use it too much, you'll have an entire application full of singletons. That's not desirable. So that's not desirable because, for example, a lazily instantiated singleton causes delays because the first time it's used, it will have to construct the objects it needs. And in a web application, we all know how important it is that we respond to requests quickly, within 100 milliseconds, for example. These requests must be satisfied. So that's a problem. If it's eagerly loaded, well, you have a situation where at startup it's slightly slower. That's perhaps not a problem. But also, you have objects that are in memory, consuming memory, and perhaps they never actually get used. So you're consuming memory without actually using it. So this can cause memory problems. It swings and roundabouts. So what's ugly about it? Well, it's considered an anti-pattern. There are many people who argue that you should never, ever, ever use a singleton in your code. There are those who argue that they are answer to all evils. And there are those who are slightly more moderate and say, well, actually, they can only be used in certain niche case situations, such as loggers and pool managers and other related situations. In fact, singletons are often used quite substantially and quite heavily by frameworks. Spring famously uses singletons quite a lot. But in the end, it might actually be smarter to use a stateless session bean. And we'll have a look at session beans, or in this case, a facade, later on in this presentation. So let's have a look at the factory pattern. Well, the factory pattern is a creational pattern. It's a pattern that is responsible for creating an object and decoupling the creation of the object from its use. And the CDI container is a perfect example of how this decoupling this decoupling exists. You know, in one part, it creates the objects and then makes them available for injection over here. And where it's being injected, we don't really care so much about the type, or don't care so much about the construction or how it's constructed. All we really care about when we want to use it is that we have it. We have this object, and we know what the object's interface name is, and we know how to inject it and how to use it. We don't really care about its construction. And this is what the CDI framework actually gives us. And in traditional implementation, it is often implemented as a singleton, or can often be implemented as a singleton. So let's have a look at how our CDI framework acts like a factory, kind of operates like a factory. Okay, it's debatable whether it really is a factory. It's not. It's actually a dependency injection framework, but let's just, for argument's sake, say it's like a factory. It creates an object over here and then makes it available for injection over here. Okay, it divorces or decouples the creation from the use. So here's a very, very simple example of how this happens. Here we have a class which implements the drinks machine interface, and the coffee machine class is a POJO, which is instantiated by the container and made available for injection at a qualifying injection point. And in this case, the qualifying injection point is marked here using the interface. We all know about programming to interfaces. This is an example of that. This is great. This works perfectly without any problems. But what happens if we have more than one concrete implementation of the same interface? Multiple concrete implementation causes problems. Here we have two concrete implementations of the same interface. Which drinks machine object is it going to inject? Okay. The container doesn't know, and on startup, it will throw an ambiguous dependency error and saying, I don't know, I have no idea which one you want me to inject, what am I going to do? Well, two options. One, don't program to interfaces, that's valid, debatable, valid. Or we can use something called qualifiers. Now, qualifiers allow us to disambiguate injection points. And here, this is how we construct a qualifier. This qualifier is called soft drink, and As you can see, its retention policy is runtime, so it's available at runtime. And the target is where you can inject, where you can actually have an injection point, and where you can use this. In this case, only method and field. Other possible injection points are type and parameter. So here, we can only use this qualifier in methods and fields. And here is another qualifier, coffee. So we have two, soft drinks and coffee. And this is how we use them. So we annotate the concrete implementations respectively. One is annotated as coffee, the other soft drinks. And then we annotate the injection points. We annotate one injection point, soft drink, and we annotate the other one, coffee. Now, the container knows where to inject the concrete implementations, because we've given it explicit typing. We've given it explicit instructions exactly where it should exactly where it should inject those concrete implementations. However, what about our beans that are not qualifying POJOs? What about our beans that do not conform to our JSR 299? I want to make my object, my wonderful object, I want to make it available for injection. I want to inject it because I really like CDI. CDI is a wonderful way to create and inject objects and to decouple the creation from the injection, or the creation from the use. So how do we do that? So let's dive deeper and have a look at an example. We can use producer methods. Okay? So here, in this example, we have annotated this method, getLibrary, produces. And what this does is that it produces a list of book objects. Okay? So imagine that we have a library application. We want to have a list of book objects. And we want this list of book objects to be made available throughout our application. So we annotated produces. And by default, we have a scope. We have a scope on this, which determines when this method gets called. Okay? When does this method actually generate our object? Well, that is determined by its scope. And by default, without any annotations, it's dependent scope. That means that every time we inject, like you see below, this object into one of our instances, this method gets called. Okay? And so perhaps this method calls the database and it gets a list of books. So every time it's injected, it will connect to the database and get a fresh list of books that are available. And we can also use qualifiers to disambiguate the injection point as well. So qualifiers come in again, very handy for making things disambiguated. So talking about scope is actually quite interesting because we might not want a new list of books every time it's injected. I mean, that's pretty heavy. If you're having to connect to the database every single time that this object is injected, that's a lot of work. We don't want to do that every single time. So in a web application, you might want to annotate it request scope or even session scope. So for every single HTTP session that this participates in, this method is called. Okay? So every time you log into your library application, you get yourself an HTTP session, that's when this method is called. And then for the duration of that session, the object is the same object that was originally created when you logged into the application. You might decide that request scope is better if you want the frequency of that object to be updated. Perhaps request scope is more appropriate in an application where books are being sold rapidly. Amazon, I would imagine, will probably want it request scope. A local library, probably session scope. Depends on your use case. So what's the good, the bad, and the ugly? Well, very easy to implement. You actually don't have to do very much. You just have to have a POJO and inject it somewhere. Okay? So no boilerplate code at all. You're not having complicated factories with factory methods and static initializers and singletons and all this kind of stuff. It's all done for you. The container takes care of that for you. And it kind of works. It just works. You know, the container does it for you. It doesn't make mistakes. It needs disambiguation at some point because you are using concrete implementations with the same interface. But that's fine. We've seen how to resolve that. So any object can be made injectable. I mean, anything. We've seen how a list can be made injectable, but almost any object that can be instantiated as a concrete object can be made injectable. including objects from third-party libraries. They can also be made injectable, which is actually quite an exciting prospect. And we use qualifiers to disambiguate or to filter. And we've seen how we can filter using the history annotation and disambiguate using the coffee and the soft drink. So there's two valid uses for qualifiers. So what's bad about it? Well, not a lot, other than the fact that if you decide to use named annotations, it's not type safe, okay? Don't use it, problem solved. What's ugly about it? Well, object creation is hidden. Well, yes, of course, that's what it's all about. But that can actually lead to an execution flow, which is quite hard to follow, okay? But if you're using a modern IDE, which you all should be, like IntelliJ, for example, you will see a little symbol on the left-hand side of your, where you have your injection, and if you click on that, it'll go through to where it's being produced. So actually, using an IDE will remove the issue with regard to execution flow. So let's have a look at the Façade pattern very quickly. A Façade pattern, well, the Façade pattern is designed to hide the complex logic of a subsystem. It provides a number of methods to a high-level methods. Perhaps they provide these methods to a GUI layer or some other layer within your application. And in Golf, very simple to implement. Really, all you need to do is you call your class something like service or facade, and then it's assumed to be stateless. Okay? So the simple definition is that it hides complex logic and provides an interface to the client. Okay? Well, this sounds familiar. This is essentially the core part of abstraction, one of the core principles of object-oriented design. So what is special about this, and why does it deserve its own name and place in the catalog of design patterns? Well, it's not merely about creating abstraction, but creating a specific type of abstraction in an enterprise system. You have a layer called the application layer that describes at a high level what that part of your application subsystem actually does. And this is really what you are doing with the facade. You are describing these high-level abstractions to any user above that layer. Like I said, perhaps a GUI layer. They are taking in very simplistic terms to the facade, the terms of accessing it, which is via simple methods. So why does this deserve something special in Enterprise Edition? Well, in Enterprise Edition, it's slightly different. In this case, Java EE has a specialized annotation. Okay? We have an annotation which we use to annotate facades. And the annotation that which is the annotation I talked about earlier when I was talking about singletons, and that is a stateless annotation. It is essentially a marker to denote that this is a facade and that it is intended to be stateless. Okay, and to describe atomic operations at the application layer. So it can do some very useful things as well. It's not just an annotation for marking a class, a facade. It actually comes with some benefits. So it's entirely thread safe. Okay, it's entirely thread safe. So when you access it, it will be thread safe, but it's not a singleton. Okay, how it is made thread safe despite not being a singleton, that's beyond the scope of this talk, but essentially it involves some container magic. Okay? The container manages it for you. Because it is thread safe and stateless, you will never run into thread safety problems. It is by default transactional, and it is useful for that layer, for that tier of your application, to be thread safe, as you would normally want those high-level use cases to be transactional. Also, it includes things like monitoring management, as well as pooling, and more importantly, defining upper thresholds for pool sizes for those services. So it is very useful for defining high-level, scalable APIs. So what's good about it? Well, it's very simple, it's robust, it gives you a range of additional services I discussed. What's bad about it? Well, overuse introduces unnecessary layers, okay? If you don't need it, don't use it, okay? You don't have to have lots of layers within your application. You don't want a lasagna application, as it's often referred to as. And what's ugly? Well, nothing really. It's just an annotation. It's actually quite beautiful. But let's have a look at another way in which Java EE has changed the way we implement common design patterns. The decorator. Okay, so this is a structural pattern. It adds dynamic logic at runtime. It's much more flexible than inheritance, and much more flexible than inheritance. And in the classical implementation, you have to implement an interface on both the target and the decorator object. So let's have a look at how this is done in Enterprise Edition. So here's a product class. And we are going to be decorating concrete classes, concrete implementations of product. And we're going to call it our price discount decorator. So what happens here is we annotate this class at decorate in order to identify that this is a decorator, and the container will know that this is a decorator that decorates product classes, product instances. And we annotate our injection point. So here, all of our instances of product are injected, essentially, into this injection point here. And we can use our, we can use our favorite qualifier, coffee, to disambiguate again. Here, only products that are annotated coffee are injected. And if we want to, we can have more than one decorator, but we need to define the order in which these decorators are implemented. So here we can identify a priority in which they are executed. Okay? But in this case, we only have one decorator. And what happens is that an object is going to be injected here into product. When its generate label method is executed, this method is executed. The price is discounted by 50%, and then the original getLabel method is called. So what's good about this? Well, it's very easy to change the behavior without breaking legacy code. And essentially, this is really only when you're going to be wanting to use it. So you've got legacy code, you can't touch it for whatever reason, but you can decorate it. So you can add additional functionality to your code by decorating it. It might need the bad. Well, what's bad about it? Well, you might need to use XML configurations in CDI 1.1. This is what's necessary. However, as you've seen, I've shown the latest edition, and this does not need to use XML configurations. Although with XML configurations, there are additional benefits which you can convey by defining precisely where in your application these are executed. And the ugly, well, again, overuse will introduce some execution flow issues. Again, if you have a good IDE, you should be able to avoid those. Again, in your IDE, in IntelliJ, on the left-hand side, you have a nice little symbol, which if you click on, goes through to the decorator. So, okay. Let's have a look at another pattern. Almost there. So, the observer pattern. Now, this is a really interesting pattern because it's a little bit difficult to understand why it's needed in the first place. And it goes down to the basic fundamental requirements of object-oriented systems, which is to pass a message from one object to another object to inform of some change of state. Okay, so it involves some methods on a dependent object, is that you care about decoupling. You want to decouple the communication in some way. So this is where the observer pattern comes in. And you want to do this because you want to change at runtime which subscribers are executed, which subscribers are informed of the change of state. So let's have a look at how this is defined in Enterprise Edition. Well, very simply, we need to create an event class, because what we're doing is we're firing events through our system. This is how we manage it. So we have an event class. This is a very simple example of an event class that contains a message, a very simple message. Once we have an event class, what we need to do is we need to create a way of publishing our event. Okay? And we do this quite simply by creating an event listener, an event manager, and injecting into this the events that we want to fire, and by calling the fire message, what we do is we can create our message. In this case, it's a hello world message, and what this does is it creates an object and fires it throughout our application. It creates a message event and fires it throughout our application, ready for any observer to listen to. And this is how we pick up the event. We have another annotation, observes annotation, and we can annotate here. In this case, we're annotating the parameter to a method, and we're annotating it with a type message event. So any event throughout the system of this type, of measures event type, is picked up by any other method that has this observes annotation. And in this example, we're just simply printing out the message. And we can use, again, qualifiers to filter our events. Perhaps, for example, we are firing messages throughout our system. In this case, we are firing warning messages throughout our system, and we want to only, in this particular instant, listen to warning messages. So what's good about this? Well, it's very easy. There's no boilerplate code involved. It's lightweight. It's less than JMS. Now, for example, imagine a use case scenario where you want to fire messages throughout your system. You want to communicate something has happened within your system, but is not significant enough or important enough to actually implement some kind of heavyweight messaging system. This event system is actually very, very, very useful. It's very lightweight, very easy to set up, no complicated configuration whatsoever. So it satisfies that particular use case scenario very well indeed. What's bad about it? Execution flow. Again, I keep harping on about execution flow, but if you're using an IDE, it actually helps. Again, IntelliJ has a nice little symbol that you can click on, which takes you through to the point where the event has been fired. And what's ugly about it? Nothing. It's actually quite beautiful. I actually really like this, this message. It's very, very useful for creating decoupled systems where you're communicating backwards and forwards between different parts of the same application. Okay, so almost at the end. Final conclusions. Well, what is so great about all of this that I've spoken about? Well, it gives us some efficiency savings. So what you're doing is by using these annotations is you're really focusing not on the code, but on the business logic. You're focusing more on getting things done rather than how to get them done. Okay? You're becoming more efficient. And of course, this is when you're working in a commercial environment and you're working for clients, this of course is exceedingly important. You need to be efficient at what you do and program as quickly as possible. We've all been there, we all know what that's like. And also, it actually gives us greater control. I mean, we've seen with the Singleton pattern, how we now, with a very few annotations, have quite a lot of control over the way we manage our singleton. We can control how it starts up, we can control its concurrency, we can control its instantiation is linked to the successful instantiation of another bean that we are dependent on in order for our creation of this singleton bean. It gives us greater control. And these new features, well, they've enhanced the implementation, like I said. They've given us additional characteristics, additional features to patterns that we are all very familiar with and that we are all very knowledgeable about and that we know. So, thank you very much for listening to my presentation. I'm not sure we have time for questions. 5 minutes for questions. Okay, yes. We have five. Okay, we do have a few minutes. One question? Up to three questions. Okay. Okay, questions.
So when you talk about Decorator Pattern, you say that it is more flexible than inheritance. And can you explain what do you mean? And is it true that you proposed ever used Decorator Pattern instead inheritance? Or it is not true that in which cases we should use inheritance and which Decorator Pattern?
Okay. Actually, I think that was 3 questions in one. But okay, basically, well, the decorator pattern is really a fix to a problem that actually somebody else caused. So really, it's used to fix old code that you can't touch for some reason or another. Okay, it's used not as part of your design necessarily. You don't set out to use a decorator pattern. You use a decorator pattern because you or somebody else has coded something in a way that lacked foresight. Okay, so you're having to fix something. So it's not a case of using the decorator pattern instead of inheritance necessarily. It's using the decorator pattern because you have to, because that's actually the only way that you can fix the problem, because inheritance doesn't fix it for you, for one reason or another. Okay? Does that answer your question, I hope? We can speak later if you have more questions. Anybody else? Another question? One more, I think. This gentleman here, please.
What do you prefer to use, annotation or XML description?
I'm sorry, I didn't understand the question.
What do you prefer to use, annotation or XML description?
Annotations.
Why?
Because XML is difficult to read. When you read XML, you have to read it twice. You read it this way, and then you read it that way. And for me, annotations are, particularly in an IDE, they're inside where your code is. So at the same point as your code. You've got your code, and then you've got your configuration within the code. With XML, you've got your XML here, you've got your code over here. So there's something slightly divorced. So it's slightly more difficult to work with. And with one single annotation, you can actually do a lot more than you can with several lines of XML configuration. So again, it comes down to efficiency savings, it comes down to ease of use, it comes down to just having things where you actually need them to be, and the configuration, you need that configuration to be in your class, because that's what you're working on at the time. But you know, if you have a history of using XML as a configuration tool, then you're probably accustomed to using that way. And that's fine. I'm not saying that XML is inferior and you should never use it. You should. It's actually very useful and very helpful. So I think that's all for questions. If you have any questions, please come and see me later. I'm hanging around for the rest of the day, so by all means, grab me and we can have a chat and a coffee. I think I now have to hand over to the next speaker. Thank you ever so much.
Thank you, Alex. And we need another 2 minutes to set up and switch laptops and prepare for next presentation.